All right, here we go, picking up where we left off in class number 7. Pablo found a new radioactive material called zeldonium. It has a half-life of 5 years. The math office had an initial amount of 3 grams of zeldonium in 1986. The amount of zeldonium, A, remaining can be described by the exponential function A equals 3 times 1/2 to the power of t divided by 5, where t is the number of years since 1986. Part A. How much zeldonium did the math office have 10 years after 1986? So let's do that part first. So part A. So we're given the equation that we need to use, right? It's right here. The amount of zeldonium is equal to this guy, where you could plug in a value for t. So tell me, where do I plug in these 10 years? Do I plug it in for A or do I plug it in for t?
T.
For t, exactly. Good. So it's going to be A equals 3 times 1/2 to the power of 10 divided by 5. Now, if you want to, you can go ahead and enter this all in one go in your calculator as is. Or if you want to, you can also simplify the exponent. 10 divided by 5 is 2, right? So, I mean, if it's a nice, easy exponent to simplify, feel free to do so. Or again, just enter it all in one go, whatever you're more comfortable with. Either way, though, you should end up with 0.75 grams. So after 10 years, the math office has 0.75 grams of zeldonium remaining. Any questions? Okay, part B. Make your own table of values to find out the first year when the math office had less than 2 grams of zeldonium. So this is almost a little bit like a guess and check type of question because it says to make your own table to figure it out. So let's make a table. So years after 1986. And then the amount of zeldonium. So let's just start with 1 year after, and let's see how much zeldonium we have left. So that'll be A equals 3 times 1/2 to the power of 1 over 5, because you're plugging in 1 for t. And that would be your calculator. I'm going to be rounding these to 2 decimal places. So that would be 2.61, and feel free to double check that in your calculators. So have I figured it out yet? Am I less than 2 grams of zeldonium? No, not yet. So just keep going. So now I'm going to try 2 years. So the amount equals 3 times 1/2 to the power of 2/5. Again, that's calculator. Plugging that into your calculator, rounding into 2 decimals, you should get 2.27. How about now? Am I done? Nope, we're not below 2, so we gotta keep going. Now let's try 3 years. A equals 3 times 1/2 to the power of 3/5. Using your calculator, that is 1.98. Am I done? Yeah, because we're finally below 2 grams of zeldonium. We got just below it finally. And it took 3 years to get there. But we can't just say 3, right? We need to say what year we're in. So 1986 plus 3 years later will put us in 1989. So in the year 1989, do we finally have less than 2 grams of zeldonium? Question?
Spencer, do you want us to do the chart, or
Well,
because I automatically went to 3 years ahead, and that's why it came out to 1.9.
Well, yeah, and that's fine, but then maybe you want to just double check the year before, because what if it was 1.99 here? You know, because then you could have gotten closer.
Why would you add the 3 into 1986?
Oh, so 1986 is when they first got the Zeldonium,
Oh.
and then it falls below 2 grams 3 years later. So to figure out what year we're in, we take our starting year, 1986, add the 3 years it took to get below 2.
Okay.
Any other questions? Okay. Number 8. The value of an iPhone decreases by 15% each year after it is released. Ross bought Rachel a new Ross and Rachel, friends. Ross bought Rachel a new iPhone for $1,000 in 2020. Part A. Use an exponential model to create a function that gives the value v of the iPhone t years after 2020. Okay. So, let's start with that. Part A. And it's decreasing by 15% each year. So that means we need to set up an exponential model. So y equals a times b to the power of x is in the general, just very broad and general form of the exponential model. Of course, though, we do need to substitute x and y using the variables provided. So instead, we're going to do v, the value of the iPhone equals. Right, the value of the iPhone equals. And then remind me, what does A represent in the form of an exponential model? What's A? In general.
Initial value?
Initial value. Yeah, it's the initial value, right? So what's the initial value of this iPhone? $1,000. So in place of A, we put in 1,000. Times B, the base, which, I changed my color here. Which, if it's helpful for you, remember you start off with 1, right? You start off with, I'll do it off to the side. I'm gonna do it like over here. Start off with 1. And then you add or subtract the percentage depending upon whether it's increasing or decreasing. Is this iPhone increasing or decreasing in value? Decreasing. It's decreasing. So we're going to subtract. And it's decreasing by how much? 15%. But then let's rewrite that as a decimal. 1 minus 15 is 0.85. So our base is 0.85. Basically, this is saying that the initial value is $1,000, and then every year it only maintains or keeps 85% of its worth. And then to the power of what? Instead of x, we're going to do what? So instead of x here, what variable should we be using?
Variable?
It's a variable.
2?
V?
Wait.
It's not a number. It's a variable.
Instead of x?
Instead of x. So remember, I just want to put t. Yeah, t. Yeah, to the power of t. Because that's what they said here, right? Use an exponential model to create a function that gives a value of v, so v, of the iPhone t years after 2020. So t.
Would that really matter, like in the test?
If the variable is specified, then yes, I want you to use the specified variable. If it doesn't say what variable, then you can use whatever variable your heart desires. Okay, part B. Rachel wants to sell her iPhone in 2024. How much should she expect to sell it for? So what do I do with that 2024? Can I go straight to plugging it in for T?
You gotta subtract the years.
Good, you have to subtract the years because T isn't the year. T is the years after 2020. So you have to figure out how many years have passed. So 2024 minus 2020 is 4. Now what do I do with that 4?
Plug it in for T.
Now we could plug that in for T. So the value of the iPhone is equal to the $1,000 it originally cost times the 0.85 worth it maintains for 4 years, 4 years later. Using your calculators, you'll see that the value of the iPhone has dropped down to $522.01.
So if we were to solve a, like, we didn't leave it like that, would that still be wrong? Would that be wrong?
Leave what?
Like, I don't know, for some reason, when I did A, actually, you can't really solve it.
Yeah, there's no solving here. So this one was asking you just to create a function. Create a function, there's no solving, no nothing. It's basically just come up with the equation.
Okay, but like if we accidentally solved it, would be wrong?
Yeah.
Okay.
So wait, what gave it a way to use that formula y is equal to a?
Yeah.
Oh, because it says it's decreasing by 15% each year. That's exponential. Yeah.
Would that apply to all of them, or we're gonna have to identify what exponential is?
You potentially would have to identify it. Exponential.
Wait, what's increasing then?
Yeah.
Say again?
If decreasing is exponential, what's increasing?
Well, increasing also. If this I said increasing by 15%, like let's say it's some rare iPhone that like is a collector's item, it could be increasing by 15%. But the key thing is that year over year, it's increasing by a percentage. It's versus a linear function. A linear function would be like the ball is falling, or not the ball is falling. Let's say I'm eating pizza at a constant rate of 2 slices a minute, right? Like it's staying the same.
Yeah. So
2 slices a minute.
I
That'd be.
So if it says decrease, you subtract. If it says increase, you add.
Correct. If this had said increase by 15%, the difference would be that this would be a 1 plus 0.15, which makes sense because then your base would be greater than 1. Because remember, when your b is greater than 1, that means it's a growth rate.
On
And
the test, is it gonna say exponential?
It may not. It may not.
oh yeah, because I was gonna say if it said exponential or linear.
Yeah, you have to be able to identify.
Okay.
Good questions, guys. Any other questions? Okay, number 9. The area of a circle is given by the formula A equals 3.14 r squared, where r is the radius of the circle. Find the radius of the circle with area 200 square feet. So it gives us the equation, which is nice. What do we do with that 200? Do we put it in place of A or do we put it in place of R?
A?
Put it in place of A, yeah. Because it's giving us the area. It says find the radius. That means we don't know R. We don't know the radius. Given the area is 200. So plug in the 200 for the area A. 200 equals 3.14 times R squared. We can divide both sides by 3.14. Feel free to use your calculators. And I'm going to 3 decimal places. Remember, go to at least 3 decimal places as you're working through this process. And then at the very end, you could round to whatever it says. Typically, then says round to 2. So this will be 63.694 equals R squared, because the 3.14 is canceled. Then to get R alone, we got to get rid of that power of 2. To do so, we apply the square root property, which tells us to take the square root on both sides. On the left-hand side, using your calculator, the square root of 63.694, rounding to 2 decimal places, is 7.98. And on the right-hand side, that square root and the power of 2 cancel, and you're left with R. And that is it.
You wanted the last one to be rounded to 3 decimal places?
The last what?
Like our final answer? Or
Oh, no,
okay.
I want to round to 2, so.
Okay.
So this one would be quadratic on the worksheet?
This is an example of a quadratic equation because the highest exponent is 2. Any other questions? Okay, number 10. Fill in the blanks. Now, what this part is really that very last portion that we did today in lecture. So fill in the blanks. In a linear model, when the input doubles, the output what? Do you remember what we did in class? For linear, when the input is doubled, the output is doubled. In a quadratic, when the input is doubled, the output is, what was it?
Isn't it 2, 4?
Mm-hmm. Yeah, multiplied by 4. Multiplied by 4. And then lastly, in a cubic model, when the input doubles, the output,
Multiplied by 8.
8. Yep, multiplied by 8.
In the formula sheet, can we write these down or not?
But thank you for asking. And that is it. All right, so I'm going to go ahead and stop this recording. And if we come up with more questions, I'm going to restart the recording. So for those of you watching, there might be a third video. Keep a lookout for it. Let me stop.